Today in science class, we're going to continue our study of matter and look specifically at how particle motion influences the different states of matter and the behavior of fluids that we've been studying in relation to Chapter 4. We're going to take a look at two IXL activities, J.1 and J.2 today. IXL J.1, click on this link and open it up. J.1 says, how does particle motion affect temperature? How does the motion of the particles in something affect the item's temperature, which then probably relates to the state that it's in terms of being a solid, liquid, or gas and the properties that it might have. Remember that temperature is a measure of kinetic energy. Every substance is made up of particles. The temperature of a substance is related to the kinetic energies of these particles. If a substance is hot, its particles tend to have a large amount of kinetic energy. The particles in a substance have kinetic energy because they are moving. The particles that are constantly in motion, even if the substance does not appear to be moving. Select all the statements that are true about the rubber ball shown above. The particles that make up a ball are moving when the ball is not. We know that all particles are moving, even in that solid, liquid, or gas state. They just move differently. The higher you go up in the state in terms of the liquid and the gas have more motion of those particles. The temperature of the ball depends on the kinetic energies of the particles that make up the ball. That's true. If the ball is cold, its particles tend to have a small amount of kinetic energy. That's true. If something is hotter, it has more kinetic energy. If something is colder, it has less kinetic energy. This is kind of how you explain how a thermostat works. Like all substances, the liquid inside a thermostat is made of moving particles. When the temperature of the liquid increases, the particles gain kinetic energy and they move farther apart because they're moving faster. When the particles move farther apart, the volume of the liquid increases slightly, and this change in the volume causes the liquid to rise up the small tube inside the thermometer. When it gets cold out, those particles condense and move closer together, therefore it slides back down to show that decrease in temperature at the same time. Next question. The kinetic energy of a ball or any other object depends on its mass and speed. The same is true of kinetic energy of a particle. Click the blue words to correct the sentence. The less mass a particle has, the higher the particle's speed, the more kinetic energy the particle has. I think it's the more mass a particle has and the higher the particle's speed, the more kinetic energy it has. So mass and speed are the two factors that are calculated when talking about a particle motion and its effect on temperature. Temperature is a measure of the kinetic energy of particles in a substance. However, because the particles in a substance move at different speeds, the particles can have different amounts of kinetic energy. So what does temperature actually measure? Temperature measures the average kinetic energy of particles in a substance. When the particles in a substance have a higher average kinetic energy, the substance has a higher temperature. Imagine a substance made up of 1,000 particles. Which of these describes the average kinetic energy of the particles? If you know how to calculate average from your mathematics skills, you know that you take the number of items that you're measuring, add them up, and then divide by however many items you had. Well, let's take a look at which of these statements has that same type of mathematical relationship. Sum of the particles of kinetic energy divided by 1,000, the total kinetic energy of the particles plus 1,000, kinetic energy of the fastest particles multiplied by 1,000. Here you have the sum, meaning you're adding up all those kinetic energies and then dividing by that number. That's how you calculate average. Add up the total and divide by the number that you had as you're adding up. Temperature is related to the average kinetic energy of particles in a substance. Even when a substance is at one temperature, its particles are not all moving at the same speed. This graph shows two different temperatures, 77 degrees and 100 degrees, and different particles moving at different speeds, yet they have different temperatures because of the overall average. The higher the average temperature of something, obviously the more faster moving particles there are. The lower the temperature of something, the more slower moving particles there are. A substance has a higher temperature when its particles have a higher average kinetic energy. Imagine two different substances that are both pure, meaning they each contain only one type of matter. Each substance has a different temperature. Which two properties determine which substance has the higher temperature? Well, we know that the average speed of the particles in each substance determines that, and the mass. We're going to take the mass of one particle because it's talking about a pure substance, so it's just the difference between those pure substances would create that difference in temperature. Take a look at the gases in these two jars. The diagrams below show two pure samples of gas in identically closed containers. The color balls represent the particles in each sample. The mass of each particle is the same. The particles in sample A have a higher average speed than the particles in sample B. Which particles have the higher average kinetic energy? Well, a higher speed is factored into higher kinetic energy, so we're going to say the mass of each particle is the same. The particles in sample A are at a higher temperature. Consider the same two pure samples of gas. Particles in sample A have a higher average kinetic energy than particles in sample B, which has the higher temperature. Higher average kinetic energy, sample A. What's the coldest temperature in the world? Fun fact, absolute zero is the temperature which no more kinetic energy can be removed from matter. In everyday temperature units, absolute zero is negative 459.67 degrees Fahrenheit or negative 273.15 degrees Celsius. You might hear the particles in a substance stop moving when the temperature reaches absolute zero. However, even at absolute zero, matter still has a tiny amount of kinetic energy that cannot be removed. So particles at a absolute zero are still moving just a little bit. Diagram shows two pure samples of gas in identically closed containers. Each particle in sample A has less mass than each particle in sample B. All of the particles are moving at the same average speed, which has the higher temperature. If sample A has less mass, then sample B is going to be at a higher temperature. Imagine two pure samples of gas in identically closed containers, sample A and sample B. Sample A has a higher temperature than sample B. Each of the statements below is true about the samples. Which statement describes a property that contributes to the difference in temperature? Select all that apply. We talked last time that the properties that influence the temperature are the average speed and the mass. So let's look at what we have here as options. Total mass of sample A is higher than that of mass of sample B. The particles in sample A have a higher average speed than particles in sample B. Each particle in sample A has more mass than each particle in sample B. So the two factors are mass and average speed. Here average speed is calculated in, and these two both talk about mass. If we're getting to the differences between two pure substances, the difference isn't going to be in the total mass, it's going to be in each particle in the sample. Think about what you've learned about particle motion as it relates to temperature. Select all the statements that are true. All the particles in a substance are moving at the same speed. That's not true. The total kinetic energy of the particles in a substance determines substance temperature. It's not total, it's average kinetic energy. How hot or cold a substance is depends on how fast its particles are moving. That's true. If the particles in two pure substances have the same average speed, the substance must have the same temperature. That's not true because mass is another factor that is determined. Hopefully that helps. Now that we're done with the J.1, you're going to go back and click on J.2. J.2 is also related to particle motion and energy, but it's asking how does particle motion affect changes of state? In lesson 2 in our study in chapter 4, we learned all about these changes of state from solid, liquid to gas. From solid to liquid, we have the melting point and freezing point. From a liquid to gas, we have condensation or evaporation that's happening, our boiling point. Let's take a look at how that factors into particle motion as well. Most of the substances around you exist in three common states of matter, solid, liquid, and gas. In each state of matter, the particles in a substance behave in different ways. In a solid, particles are packed together tightly. In a liquid, particles are close together, but they are able to slide past one another. In a gas, particles are spread far apart and they move quickly. Match each state of matter to the correct diagram. Solid, liquid, gas, just based on which one has particles that are farther apart. There's another state of matter that we learned about, and that's plasma. Plasma is found in all different parts of the universe, but it's not one we're going to focus on and study as much because it's not prevalently found as much on Earth. Particles in each state of matter behave differently because they have different amounts of thermal energy. In a solid, the particles are held together tightly and they do not move around freely. Because the particles stay in a sample in the same space, a solid generally keeps a certain shape. Even though particles in a solid cannot move past one another, they are not completely still. The particles are constantly vibrating or moving back and forth in place. Select all the true statements. Particles in a solid are completely still. We just read that that's not true. Particles in a solid are packed tightly. That's true. Particles in a solid have thermal energy. Thermal energy is going to be that movement of those particles. Here it says in a solid the particles are held together tightly and they do not move around freely. Because the particles stay in the same place, the solid generally keeps a certain shape. Even though particles in a solid cannot move past one another, they are not completely still. The particles are constantly vibrating or moving back and forth in place. So then they can have some thermal energy. What happens when you heat a solid? Heating a substance increases its thermal energy. When the particles in a solid have more thermal energy, they vibrate more quickly and the temperature of the substance goes up. Once the substance reaches a certain temperature, called its melting point, the substance can begin to change state. As more thermal energy is added to the substance, it gains enough thermal energy to move around more freely. The particles remain close together, but they are able to slide past one another. When all the particles have broken out of their fixed positions, the substance has changed state. Which of the following happened during this change of state? Select all that apply. So you could count all these particles to see if there's a different number of them, but there's not a change in the amount of matter that's happening here. So the number of particles doesn't increase. The substance melts and becomes a liquid. Looks like that's happening. The particles in the substance move farther apart. So they were all packed together. Now they're slightly more spread out. I guess not. They're not saying that that is not really spread out, even though I'd argue that that's the opposite. They do move further apart, but they're, I guess, not spread out because they're still in this connected state in that liquid form. My fault. Particles in both solid and liquids are arranged close together, but when a solid is a liquid, its particles have more thermal energy than they would if the substance were a solid. Particles in a liquid can slide past one another because of how these particles move. A liquid is able to flow and take the shape of its container. Complete the table. Particles move around one another. That's a liquid. Substance shape does not depend on its container. Solid. Particles always stay near other particles. Those are both true, as we just learned. What happens when you heat a liquid? The particles begin to slide past one another more and more quickly, and the temperature of the substance goes up. When the temperature reaches the substance's boiling point, the particles have enough thermal energy to begin moving far apart and escaping the liquid. Which of the following can happen when a liquid is heated? Select all that apply. Particles gain thermal energy. The mass of each particle increases. That's not necessarily true. The mass can stay the same even though it has more energy. The substance vaporizes and becomes a gas. When it's heated to a certain point, that's where that boiling point takes place. Evaporating into thin air. Liquids do not need to be heated to their boiling point in order to change into gases. In fact, some of the liquids around you may slowly change into gases. The particles of the surface of the liquid can vaporize and form a gas through the process called evaporation. We learned that vaporization happens in two forms: in boiling inside of the liquid and evaporation at the surface of the liquid, where those particles are moving at a faster rate than other particles throughout the liquid. In a gas, particles are far from one another and constantly moving in different directions. The particles in a gas have more thermal energy than they would if the substances were a liquid. So when a substance is a gas, its particles move more quickly and can spread farther apart. Place each statement into the correct column. Particles are spread far from one another. That's a gas. Particles are arranged close together. That's a liquid. Particles do not stay in the same position. Liquids and gases. You learn about how particles in solids, liquids, and gases behave as thermal energy increases. Click the blue words to describe how particles in a substance behave as thermal energy decreases. When a gas is cooled, the particles begin to move more slowly. When the temperature drops below the melting point, below the boiling point, the substance particles have condensed and formed a liquid. If the liquid is cooled down even more, the amount of thermal energy in the particles will decrease, and the liquid's temperature will continue to decrease. Eventually, the substance will freeze and form a solid. If the temperature continues to decrease, the particles in the solid will vibrate in place more slowly. That sounds right. Nice work. What is true about particles in a substance? Select all that apply. Particles in all states of matter are constantly moving. True. Particles in all states of matter are arranged close together. Not necessarily true because gases can be spread apart. The way particles move changes when substance's thermal energy changes. Yes, more thermal energy means more movement of those particles. Lastly, heating a substance can cause the substance to change state. True. Nice work. Hopefully that helps you with IXL J.1 and J.2. God's blessings.